My first ever AutoFlight landing demonstration, AutoFlight eVTOL here in Shanghai in China. Here it is, the future of aviation right behind me in the sky. G'day world, behind me is the AutoFlight Prosperity. This is an eVTOL passenger aircraft capable of carrying 4 or 5 passengers a few hundred kilometers, all electric, no tailpipe emissions. AutoFlight Prosperity is the passenger version of this amazing aircraft. It comes in both passenger and cargo version. Let's have a little look at ingress for what it'll be like for the passenger. So we can step up in here into an extremely roomy cabin. Now this is not a mock-up, this is a full flying functional aircraft, but it's one of the early versions. This cabin layout is a little bit different to the production versions. The production versions will actually be a 5-seat aircraft, 5-passenger aircraft. So in the front here, you'll have the pilot on one side and the passenger on one side, a little bit more like a typical traditional aircraft, and then 2 seats here in the middle, another 2 in the rear, giving 5 full passenger seats. In the cargo version of the same airframe, you'll see this sort of door is capable of receiving a full EU-sized payload. There'll just be the pilot and co-pilot seats in the front for optional manned or unmanned flight, with the full cargo bay available for a huge amount of payload. Here's what it might look like for a pilot climbing aboard the Prosperity. Wow, that's a lot of room. Much more than a traditional aircraft. That's pretty exciting. And then we get our control system down in play. You might notice there's no pedals here available. Most aircraft would, traditional aircraft would have rudder control down here, as would a traditional helicopter have foot controls as well. But the Prosperity and the equivalent cargo version are a little bit different. There is a lot of software creating an envelope of operation, a software operational envelope in the aircraft, which governs the orientation or the attitude of the aircraft digitally. This configuration is the single pilot seat, which, as I mentioned before, is not going to be the production configuration. While this particular aircraft has flown a little bit, this one that I'm in right now has flown in Dubai. It is the single pilot seat in the front. The future iterations of this aircraft, which are an identical airframe, will have a different layout, with the pilot seat on the left, which is a traditional configuration for a lot of small aircraft, and then a secondary seat on the right, which can be a co-pilot or first passenger seat. What you're witnessing here is a manual landing controlled from personnel on the ground. So the pilot is not actually in the aircraft. The pilot is on the ground controlling the aircraft. This is a beyond visual line of sight, remotely piloted cargo delivery drone, carrying up to 400 kilos of payload capacity. AutoFlight Prosperity and the cargo version, the Carry-All, are probably going to be the first commercial eVTOL aircraft to come to market. You'll have seen some early flight testing from a company called Beta Technologies, who are starting to do some early flight with their electric Alia aircraft. Fantastic machine, but it is a conventional takeoff and landing aircraft that still uses a runway. There's been some amazing eVTOL testing by Vertical Aerospace and by Joby, Aviation, and even a little bit by Umbrella with their eVTOL project. But the AutoFlight has been flying eVTOL, so vertical takeoff and landing, for many years now. The first flying prototypes with their original patent were established way back as early as 2017, and they've been flying various iterations of this aircraft in various sizes ever since, right up until their full-sized, full-capacity, current configuration flight testing in 2023. Then further revisions and further testing have continued to occur since 2023 to achieve the aircraft that we see flying today, which we had the pleasure of seeing a small demonstration of takeoff and landing at the test facility today. So it's quite likely that the AutoFlight eVTOL will be the first electric eVTOL aircraft to market, carrying passengers and cargo in bulk for the growth of the low altitude economy worldwide. One of the great things about what AutoFlight have done with their whole design ethos from the get-go is to manufacture lots and lots of redundancy into the aircraft. Got here the elevators for the aircraft, which, interestingly, you might have noticed, are on the front, on the canard wing component of the aircraft. So the elevators here on both sides have dual redundancy. So if there's a component failure or damage from a bird strike or anything like any sort of rogue anomaly like that, there's always multiple redundancies built in to help maintain the attitude of the aircraft. There's even dual redundancy built into the pitot-static tube. So in the event of a blockage or some damage, again, there's a second pitot-static tube measuring our airspeed. Everywhere through the aircraft, of course, is redundancies in the drivetrain. There are 2 motor windings in every motor, making for built-in redundancy in the motor itself, and 2 motor controllers for every motor. Now, even with multiple motor failures, and this is the case for most eVTOL aircraft, the aircraft can still maintain a level of control in vertical flight for a safe and controlled descent. As we move down the airframe, you'll see, of course, there are multiple propulsors, both on the inner nacelle and the outer nacelle, all of which govern the stability and the control of the flight during the vertical takeoff and landing phase. Now, for the forward part of the flight, you'll see there's multiple propulsors on the rear of the aircraft. Unlike some other eVTOL designs out there in the world that have a tilting rotor, which adds a lot of complexity, a lot of potential costs, and a lot of maintenance intervals, this aircraft all has fixed rotors. These tilt on no axis. The aircraft governs its stability and orientation in the vertical stage of the flight by differential control and so varying RPM of these multiple vertical propulsors to stabilize the aircraft. And then when the aircraft has reached its clearance height and is ready for forward flight, the multiple rear propulsors engage and push the aircraft through the air. At that stage, the aircraft will start moving forward and generating lift with a good old-fashioned aerofoil. This lets the aircraft have a much more efficient forward flight profile, letting the aerofoil generate all of the lift, just like a traditional aircraft. But in this case, with a pusher-prop configuration. So the propulsors are from the rear of the aircraft, a lot like some private jets, which have their engines at the rear, and some traditional aircraft as well, from way back, have employed this design. The reason you'll see it more and more in the future is now that motors are getting smaller and they can be built into tail sections like this in the aircraft. There's a lot more opportunity to start putting these propulsors in more optimal places on the airframe. The AutoFlight Prosperity and Carryall both have dual rudder control systems, keeping in line with the redundancy built into this airframe all over. So in the very unlikely event of a component failure on one rudder, we've got a secondary rudder system that's going to help govern the aircraft. As well as that, the differential drive on the multiple vertical takeoff and landing propulsors can also influence the orientation of the aircraft. One very interesting design characteristic, which we only just became aware of today, is the fact that this whole wing assembly that you see behind me actually disengages from the fuselage in just a couple of minutes. We saw it happen at the factory earlier in the final assembly plant, where they were able to crane lift the wing assembly off of the main airframe very, very quickly. This presents some really interesting configuration change options for operators and for service and maintenance of the aircraft and of the wing and motor and control assembly. The batteries are in the base of the aircraft, which is partly to do with its weight and balance requirements, not built into the wings or into the nacelles. So all batteries are at the bottom and then connected via cables through to the top system. But the brain of the aircraft, all of the flight control systems and all of the electrical components that are governing all of these management systems and that software envelope I spoke about earlier, all occurs inside the wing. And we're interested to see what sort of opportunities that will present operators in the future, where they might be able to have different configurations of the fuselage. You might see the firefighting option behind me, where an operator could have a single wing assembly but have multiple fuselages that can be swapped out for different mission profiles. This is the heart of what keeps Prosperity and Carryall flying. It's an electric motor. There are 13 of these on the airframe. The same motor for the forward propulsors as well as the vertical takeoff and landing propulsors. There's nothing too exotic going on here, just a fine quality build and a nice efficient motor. But what you might notice is that there are no attachments on here for liquid cooling, and these are an air-cooled motor. The advantage of this system having different propulsors for the forward flight and the vertical takeoff and landing flight means the motors aren't working as hard for as long. A tilting transitional rotor has to do all of its work on the vertical stage of the flight and then tilt and continue operating for the horizontal stage of the flight, meaning the motors themselves work a lot harder and need to be cooled. With Prosperity and Carryall, the vertical stage of the flight is over after about 20 to 30 seconds, maybe less, allowing for the forward stage of the flight. Now, the forward stage of the flight, the motors that are pushing the aircraft forward through the air, the propellers are pitched much differently and those motors are working far less hard. The advantages of all of that means that by not adding liquid cooling to these systems and being able to run these at a cooler temperature, that saved a lot of weight on the aircraft with the liquid cooling systems and the heat exchangers and the pumps and all the parts that come along with that. It's also one less thing to service and maintain and inspect. Again, keeping the aircraft and the drivetrain very simple. Operators love simple aircraft. I promise you this, we're an operator, we do loads of flights in various aircraft, and every little part on that aircraft that moves is something else that needs attention, maintenance, service, replacement. So anytime you can make an aircraft a little bit more simple and still meet your mission profile in a sensible time frame is a good result. We love air-cooled motors. What's this? You guessed it, it's a battery module. Carryall, which is the cargo version of the AutoFlight, will have 4 of these modules, giving us up to 153 kilowatt hours, I'm pretty sure is what they quoted me earlier. Now the Prosperity, which is the passenger version, will have a little bit more at 167 kilowatt hours. Still with the 4 modules, slightly different architecture inside. Now, what some of you might already know is that the battery supplier and one of the biggest investors in AutoFlight is CATL, which is one of the biggest battery manufacturers in the world, if not the biggest battery manufacturer. And they're responsible for a large quantity of the electric vehicle batteries that are out there. Very mature battery company, building very high quality batteries and at the very cutting edge of battery economics, battery longevity. So for them to be the heart of the design and the energy supply within the AutoFlight is very exciting. It gives us lots of faith in the maturity of the supply chain and the continued airworthiness of this aircraft ongoing. This interesting thing is the cargo deployment system of the emergency version of the Carryall. It actually holds 4 large canisters of fire retardant or 4 large inflatable life rafts in the case of this aircraft being used for recovery at sea. When fully loaded, that payload delivery system can enter the airframe here and deploy through the floor of the aircraft. For this type of configuration, the battery is not kept underfloor like it is with the regular cargo and passenger version of the airframe, but instead the batteries are stacked fore and aft of this area, allowing that payload to be deployed through the floor and letting that fire retardant or life vests or any other payload delivery mechanisms that are required to drop through the floor of the aircraft for it to return home safely. This cool bit of kit behind me is called the White Shark. Now the White Shark, it looks like a small scale model of the Carryall and the Prosperity, and it is in many ways. The Prosperity and the Carryall are more advanced aircraft. What the Shark does is not only provides a low cost means of carrying up to 20 kilos payload with potentially a lot of surveillance equipment on board for things like inspections, pipe inspections, transmission line inspections, even things like shark watch up and down our coasts, but also it provides an amazing test and training platform for the larger aircraft. So before we deploy a larger aircraft in a region or with an operator, we'll go into in-depth operational testing, and with this amazing 6-hour endurance aircraft, which will let us establish all the operational parameters and characteristics required in that area to deploy the larger aircraft successfully. It was really fantastic to get to the AutoFlight assembly and test facility today, and to come here and talk to the team and to get a really in-depth exposure to how AutoFlight have been able to get to where they are today, all their achievements to date, and just the capabilities of this amazing machine. FlyOnE is excited to be working with AutoFlight to get more of these amazing aircraft in Australian airspace. There are some amazing use cases for this aircraft: better economics than traditional aircraft, zero tailpipe emissions, lower noise profiles, and with the ability for remote operation, it means we can send cargo or emergency equipment and emergency services into difficult areas and places you wouldn't normally send a piloted aircraft. The AutoFlight platform is going to open up a lot of amazing opportunities for a lot of Australians, and we're excited to bring you that opportunity.